Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. So now we are in the lecture of 3.2 binomial expansion. Okay, in this topic, it's quite interesting because we sometimes talking about the linear or quadratic. Okay, what I'm trying to say is, okay, before that, let's take a look at the notes. Find the expansion of a plus b to the power of n, where n is a positive integer. Mostly, we're going to expand this a plus b with the highest might be n equal to 2 or might be 3. Okay, so where right n notation and factorial notation, we call this as a factorial, the sign of factorial notation, and NCR, and this one here as a binomial coefficient. And determine the general term of this. Okay, now, so just imagine that for this one example, a simple example, I do believe that all of you can answer because can handle this. Is just like as simple as A plus B. Okay. So next, A plus B squared. Okay, class, please do remember this, that this is not as simple as A squared plus B squared. Okay, so for this one, this is incorrect. Okay, so for A plus B in bracket square, it means that this is the term of A plus B square, meaning the term of A plus B appear twice. Okay, so it means that here we look the one by one. A multiplied with A, it gives you A squared. A times B plus AB. B times A, another of AB. And then B times B equal to B squared. So what about next down here? Okay, I'm sorry. I think I'm going to bring it here. A plus B cubed. Okay. So what about this one here? As I said that for this example, in bracket of A plus B squared, meaning A plus B appear twice. And what about this one here now? Okay, so just imagine that if we have A plus B and we expand this one here, this is A squared plus 2AB plus B squared. I forgot something here. Okay, meaning this represent for A plus B in bracket square. So then A square plus 2AB plus B square. Again, we are going to expand again one by one. A cube, A times A square A cube plus 2A square BA times this one here and plus with AB square plus with B times A square B, and this with this one plus 2AB square, and B times with B square equal to B cube. Okay, so now what's next? Let's expand it. I simplified A cube, okay, 2A square B, and another of A square B. So 2 plus 1 equal to 3A square B, AB square plus 2AB square. AB square and AB square, so we have 2 and 1 plus with 3AB square and then B cube. There you go. So then next, what about a plus b to the power of 4? Are you ready? Okay, so it is a plus b squared multiplied with a plus b squared. Okay, now the expansion of a plus b squared, a squared plus 2ab plus b squared, and then a squared plus 2ab plus b squared. Okay, another work. You are going to expand it such a long, then here, and then simplify. So what about a plus b to the power of 7? What about a plus b to the power of 10? And so on. So to simplify this, we are going to use what we call a Pascal triangle as a method coefficient of each term binomial expansion for an array which is known as a Pascal's triangle. Okay, this helps us to expand it, or expand what we call the binomial expansion easily. Okay, so then you have the handout with you, so just refer to that. Okay, for each number is triangle is the sum of two numbers adjacent to it in the previous row. So that okay, let's say we'd like to recall to form this triangle here. Okay, how are we going to remember all this? It's easy. Just make this one as an 1 plus 1 equal to 2. 1 plus 2 equal to 3. 2 plus 1 equal to 3. 1 plus 3 equal to 4. 3 plus 3 equal to 6. And 3 plus 1 equal to 6. So you may just continue. Let's say 1 plus 4 equal to 5. Good. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And another 1 here, and also 1 at the end here. Okay, so this is for when n equal to 5. So expansion of a plus b to the power of n. This one here, for example, a plus b cube, in bracket cube, power of 4. The power of a decreased by 1, and the powers of b increased by 1. So please refer to this one here. Is imagine that this is a power of 4, b 0, and this is a power of 0, b to the power of 4. So a power of 4, a cube, a squared, a to the power of 1, and a to the power of 0. And oppositely, the power of b increased from 0, 1, 2, 3, 4. Okay, the numbers in terms of n plus 1 then. Okay, so now example 1, use a Pascal triangle to expand a plus b to the power of 4 and this one here. Okay, now for a plus b to the power of 4. So let's take a look at this one where n equal to 4. So from binomial expansion from the Pascal's triangle, it has a constant of 1, 4, 6, 4, 1. Okay, so a plus b to the power of 4 equal to, let's begin with a here, with a to the power of 4 plus b. Now, a to the power of 4 and it decrease 1 by 1. So it means that here we come up with a power of 3 times b to the power of 1. A square times b square. Then a power of 1 times b cubed. And plus with a to the power of 0, since there is 1 here, so a power of 0 and b to the power of 4. Then next, for b, okay, the question is 2x minus 1 over 2y, power of 3. Okay, where n equal to 3 here, and there from Pascal's triangle, it has a 1, 3, 3, and 1. So now, 2x minus half y cubed equal to, okay, so we just imagine that here, which is 2x minus or plus negative 1 over 2y cubed, and 1 by 1, 2x cubed, and then negative 1 over 2y to the power of 0, plus with 2x squared. Okay, we got 3 here with 3 times 2x in bracket squared, and then negative 1 over 2y to the power of 1, plus with another 3, 2x power of 1, and then negative 1 over 2y cubed, squared, okay, sorry, squared, and then plus with 2x to the power of 0, and then negative 1 over 2y cubed. So this is 1, and this is also 1. So simplifying this, we got 2 cubed equal to 8x cubed, and this one here, 2 squared equal to 4, 4 times 3 equal to 12x squared. Okay, 12x squared. And then what about this one here now? Times with negative 1 over 2y plus with 3 times 2 equal to 6x, and this is negative half square. It becomes 1 over 4 y squared, and then plus we, okay, for negative cube become negative 1 over 8 y cubed. So simplify this, and it gives you 8x cubed minus 6x squared y minus 3xy squared and minus 1 over 8 y cubed. Okay. So next page, factorial notation. So 2 factorial is equal to 2 times 1, 3 factorial, which is 3 times 2 times 1, 4 factorial, okay, 5 factorial, and so on. So we come up with a conclusion that n factorial is n multiplied with n minus 1, multiplied with n minus 2, so on until last one is multiplied with 1. Okay, n is a positive integer. So 0 factorial equal to 1 and n plus 1 factorial equal to this one here. Okay, so example 2. 10 factorial divided by 7 factorial. Okay, so what about this one here now? It's just like 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and everything divided by 7 times 6 times 5 times 4 times 3 times 2 times 1. So 7 divided by 7, 6 and 6, 5, 5, 4 and 4, 3, 2, 1. So it's only left, what's left here now? 10 times 9 times 8 equal to 720. Method number 2, we list down here 10 times 9 times 8 times 7 factorial and divide by, okay, sorry for this, 10 times 9 times 7, 8 times 7 factorial and divide by 7 factorial. So it gives you 720. Okay, notation of n r. Let n r be the whole number with n is greater than r. Then this one is notation as NCR, which is n factorial divided by n minus r factorial multiplied with r factorial. Okay, we will see here 5C2. Okay, so what we get then? 5 factorial divided by 5 minus 2, and this will give you 3 factorial and 2 factorial. So it's just like 5 here is 5 times 4 times 3 factorial. So 5 times 4 equal to 20 divided by 2 factorial. 2 factorial is 2 times 1 equal to 2. 20 divided by 2 equal to 10. Can you write down the expansion of a plus b to the power of 5? So using the Pascal triangle, you get something like this. Okay. And then what about a plus b to the power of n? Okay, as we know that, well, what is the expansion of n equal to 5? When n equal to 5, it is 1, 5, 10, 10, 5, 1. Okay, so class, actually therefore, if I give you one example here, 5, 2. Okay, we are referring to this 10. 5 factorial divided by 5 minus 2 equal to 3 factorial and 2 factorial. So it's 5 times 4 times 3 factorial divided by 3 factorial, 2 factorial. 5 times 4 equal to 20. And 2 factorial is 2 times 1, which is equal to 2. So 20 divided by 2 equal to 10. This is it. Okay, so what about a plus b to the power of n? So if n is a element of the numbers of here, so then here it can become something like this. As you see on the screen now. So example 3, expand 2x plus 3 bracket to the power of 5 in descending power of x. Okay, example 3, expand 2x plus 3 bracket to the power of 5 in descending powers of x. Okay, so right here now we got 2x plus 3 to the power of 5, which is, okay, now 2x power of 5. Okay, the whole of 2x power of 5 and 3 to the power of 0. Then 5, 1, 2x to the power of 4 and 3 to the power of 1. Okay, class, how are we going to make sure that the power of every single term is correct? Okay, for example, actually there is another few terms that I left here now. Okay, the n is 5. So look at this one here now. 5 and 0. 5 plus 0 equal to 5. 4 plus 1 equal to 5. 3 plus 2 equal to 5. Okay, now 5, 3, 2x squared and 3 cubed plus 5, 4, 2x power of 1 and 3 to the power of 4. And finally, actually there's a 5, 0 here. And then 5 with 5, 2x power of 0 and 3 to the power of 5. Okay, every single term of this, and this, and this actually give us the group of numbers from the Pascal triangles, which is 1, 5, 10, 10, 5, 1. So just imagine there's a 1 here, this is 1, and this is another 1, and this is also 1, and this is also 1. So now let's expand, simplify this. 2 power of 5, which is 32, x to the power of 5. Okay, and this become 5 here. 2 power of 4, 2 square 4, 8, and 16. 16 times 3 and times 5 equal to 240 x to the power of 4. 5c2, which is 10. 2 cubed equal to 8. 3 squared equal to 9. 8 times 9, 72, and times with 10, 720 x cubed plus with 1080x squared plus 810x plus 243. Okay, general term of a plus b to the power of n. So this one here now, the first term is a to the power of n. This we consider as the first term. And this is the second term. T3, T4, and so on. So in general, we said in general of the term of the r plus 1 term here equal to this one here, NCR a to the power of n minus r b to the power of r. In some books, they come up with TR and NR n minus 1, n r minus 1, and a n minus r minus 1, and b r minus 1. There's some in reference book. Okay, so class, please, we are going to use this. Okay, the other one is also correct, but not to make all of you confused. Okay, so we stick with this one here. So in all the questions, we are going to use this one formula only. For binary expansion of a plus b to the power of 8, find the third term. Okay, the solution then. So the third term, so then T3 equal to, okay, so 3 r plus 1 equal to 3. So then r equal to 2. So means that the r here is equal to 2. And the third term, according to this one here, 2 plus 1 equal to 3. So we got 8 and 2. Then a to the power of 8 minus 2 and also b squared. So 8 to here, which is 28, a power of 6 and b squared. Find the coefficient of x power 5 in the expansion of 3 plus x to the power of 7. Okay, so the solution of this, find the coefficient of x power of 5. Okay, x power of 5. So according to this one means that we have the term of r plus 1 equal to, okay, the n is 7 and r with 3 to the power of 7 minus r and 2x to the power of r here. Okay, so we wanted x to the power of 5. So when it comes to this, we wanted x to the power of 5. Let's make this one here as an 2x to the power of r, which is 2 to the power of r and x to the power of r. So x power of r compare with x5 equal to xr. So then r equal to 5. So this one here now is 6th term, which is 7 and 5. 3 to the power of 7 minus 5 equal to 2, and 2x to the power of 5. What about 7 and 5? 7, 5, which is 21. Okay, 7, 5, we'd like to check it. Okay, 7 factorial divided by 7 minus 5, which is 2 factorial and 5 factorial. So 7 times 6 times 5 factorial divided by 2 factorial, 5 factorial. 7 times 6, 42. 2 squared equal to 2 times 1 equal to 2. So 42 divided by 2, which is 21. There you go. 21. 3 squared equal to 9. And 2 power of 5. 2 power of 5, 2, 4, 8, 16, and 32. And x to the power of 5. So then 21 times 9 times 32, 6048 x to the power of 5. So the coefficient of x5, the coefficient here of x power 5 is 6048. Example 6. Determine the term which is independent of x in the expansion of x plus 1 over x to the power of 8. Independent of x meaning the term without any x or x to the power of 0. Okay, so in this case, so we look at tr plus 1, which is 8r, and look at this one, the first one here, which is x to the power of 8 minus r, and 1 over x is a x to the power of negative 1 to the power of r. So we are now focusing on these two, which is x 8 minus r multiplied with x negative 1 times r equal to negative r equal to x to the power of 0. Multiplication between these two figures, remember here, with the same base, so then you come out with x to the power of 8 minus r. Multiplying means that we add these two plus, but additional with the negative r, another of negative r, equal to x to the power of 0. So x and x, the base are equal now. So we can just look at the index. 8 minus 2r equal to 0. Then negative 2r equal to negative 8 and r equal to 4. So when r equal to 4, so then r equal to 4. 4 plus 1 equal to 5. And as we know that everything here will give you, okay, all this is going to give you x to the power of 0. So x power of 0 equal to 1. So we're now looking at this one here equal to 8 and 4. So 8 and 4 equal to 17. Okay. Next. So binomial theorem. When a equal to 1 and b equal to an x, so you come up here. Okay, this one, 1 plus x to the power of n, and we're going to get this all. So, n 2, which is n factorial, n minus 2 factorial times with 2 factorial, and then n multiplied with n minus 1 minus n minus 2 factorial. We will put this one here. So cut these two. Then we get n times n minus 1, n times n minus 1 divided by 2 factorial. And what about this one here now? So cut this, divide by itself. So finally it becomes n times n minus 1, n minus 2 divided by 3 factorial. Expansion of 1 plus ax of n when n is negative integer or rational number. So now 1 plus ax to the power of n, so equal to 1 plus n times ax plus n times n minus 1 divided by 2 factorial. Okay, this is a thing that we're going to use from the previous slides. 8x in bracket squared and so on. The expansion is valid for in bracket modulus of x, which is 1 over modulus of a. Okay. Example 7. Expand 1 over 1 minus 5x in bracket square in the ascending powers of x up to x cubed term. State the value of x for which the expansion is valid. Okay, so let's continue. Okay, so 1 over 1 minus 5x squared, we simplify this, bring this all above, it become 1 minus 5x negative power of negative 2. Okay, so now it begins with 1 plus with negative 2 and then negative 5x. Plus with negative 2, negative 2 minus 1, and then negative 5x squared divided by 2 factorial, plus with negative 2, negative 2 minus 1, negative 2 minus 2, negative 5x cubed divided by 3 factorial. Okay, so let's simplify this. 1, negative negative become positive, so 2 times 5 equal to 10x. Negative 2 minus 1 become negative 3. Negative with negative become positive. Negative 5 squared is also positive, so now become positive here. Okay. And then 5 squared is 25 times 3 times 2 equal to, okay, so with this one here, negative with negative become positive. Negative 5 squared is also positive, so positive with positive, positive, and 2 divided by 2 factorial. So negative 5 squared is 25 times 3 equal to 75. And plus with this one here, which is negative 3 and negative 4. Negative times negative, positive times negative, negative, and negative cube is also negative. Negative times negative become positive. So 3 factorial is 3 times 2 times 1, which is equal to 6. 2 times 3 is also equal to 6. So 6 divided by 6, 1. And negative 4 with negative 5 squared, which is also equal to 500 and x cubed. Okay, that's it. And then the expansion is valid for, okay, modulus of x, which is less than 1 over modulus of negative 5, and which is also modulus of x less than 1 over 5, and x lies in between negative 1 over 5 until 1 over 5. Example 8. Find the first term of expansion of 1 minus x to the power of 6, and find the value of 0.999 to the power of 6 correct to 4 decimal places. Okay, so for this one here now, Okay, so 1 minus x to the power of 6. Expansion of this, it gives you 1 minus 6x plus 15x squared minus 20x cubed plus with. Okay, we simplify this. You try to expand it by yourself to get this one here now. So 0.999 to the power of 6. What's the meaning of this? It is a 1 minus 0.00, 1 minus 0.001 to the power of 6. Okay, so just imagine that this is 1 minus x. So we get x here, x, and also x. So it is a 1 minus 6 of 0.001 plus with 15 0.001 squared and plus with 20 of this 0.001 cube. So for every single this, it can give you 0.99401,498, or we simplified as 0.9940. Okay. Example 9. Expand the square root of 4 plus x descending powers of x up to the term x cubed state interval of x which the expansion is valid. Okay, so for this question, square root of 4 plus x, it is actually equal to 4 plus x to the power of half. Okay, and before we come up with expansion of this, we must make sure that the first term of this equal to 1. So in this case, we are going to factorize, take it outside, 4 power of half, and then 1 plus x to the power over 4, and then to the power of half. Okay, actually that is coming like this here. 4, 1 plus x over 4. Okay, everything here to the power of half. So 4 power of half, and also here to the power of half. Okay, so then square root of 4 power of half, which is square root of 4 equal to 2. And then 1 plus x over 4 power of half. So from here now, this is the one that we're going to expand for the binomial expansion here, which is 2. Okay, so begin with 1 plus x over 4 and 1 over 2 plus with 1 over 2 and 1 over 2 minus 1 with x over 4 squared divided by 2 factorial plus with 1 over 2, 1 over 2 minus 1, 1 over 2 minus 2, and then x over 4 cubed divided by 3 factorial and so on. Okay, now simplifying all this, we have 2 outside here, give you 1 plus x over 8 plus with, okay, so simplifying all this is gonna give you x squared divided by 1 to 8 plus with x cubed divided by 1024. Okay, so expand this, simplify this, x and x over 8, and this is half minus 1 is negative half, so half times negative half with x over 4 squared divided by 2 factorial. Simplify all this, it gives you x squared divided by 128. So just calculate, try to calculate by yourself. And this one here now, 2 times every single term that we have in the bracket, then we get 2 plus x over 4 plus with x squared over 64 plus with x cubed divided by 512 and so on. Okay, so now the expansion is valid for modulus of x less than 1 divided by modulus of 1 over 4, and it is x less than modulus of x less than 4, then x lies in between negative 4 until 4. Okay, so that's a one exercise for you to try, and you may recall, watch the videos or read from any sources or books and try to understand the content of this topic and try with this question, and hopefully that all of you will get the answers of this. The final answer is given there. So that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh and have a nice day.